Hello everyone and welcome back to one another interesting video. In this video, we are going to talk about these 5 crucial parameters about the medium voltage switchgear panel. Now these parameters are related to the complete switchgear, complete panel. Okay, we are not going to talk about parameters of any specific equipment into that, but rather we will be covering the parameters which are applicable for the complete cubicle. By the way, if you're new on the channel, my name is Gaurav J. On this channel, I simplify electrical engineering. So if you're somebody who is working in the electrical industry or want to work in the industry, you will find a lot of content that will help you to understand the concepts in very easy way, and there are a lot of content that is coming also. So make sure you subscribe to the channel to learn the concepts in the easiest way. For now, let us go and understand what is the rated continuous current of the bus bar in medium voltage switchgear. So as the name suggests, it is the continuous current of the bus bar, and this indicates that the bus bar that we have, the main bus bar, they are capable of carrying this current continuously without any problem, right? And you can see a different current ratings mentioned. So it can have 800 amps, 1250, 2000, 2500, 3150 amps, 4000 amps. In some cases, some special application, it may also go up to 5000 amp. And based on this current rating, why this is important? Because based on this rating, the design of the switchgear will change. The depth of the switchgear will change. Maybe 800 amps will have the most compact version, whereas the 4000 amps will have, the width of that will be large. So that differentiation comes. And also, as we go higher in the current rating, the continuous current rating, the thermal issues are also there. So maybe in some cases we need to provide the forced cooling. So with that, we will be able to achieve this current rating. So certainly it's very important rating when we talk about the medium voltage switchgear. Now, when I say the current rating of my panel is 2000 amp, the continuous current rating, what does it mean? It means that my bus bars are capable of carrying 2000 ampere continuously without any problem. And this is also true if the current is less than that. So if the actual current that is flowing into the system is only 1000 amps, so the switchgear is all okay with that as well. But if the current goes beyond 2000 amp, let's say it is flowing 2800 amps, so continuously, that is a problem. For that, my cubicle is not designed. My bus bars are not capable of carrying that current continuously, and it's a problem. And we can notice that in the switchgear. So certainly, the actual current that is flowing into the system must be lower than that of the rated continuous current. Now, if you see the nameplate of the panel or the product data sheet, then you will also notice two different currents are mentioned. So one is the rated continuous current of the bus bar. The another one could be the rated continuous current of the feeder, and which could be lower than that of the bus bar current. Let me explain you with one simple example. So imagine we have the rated continuous current of the bus bar 4000 amps. So my bus bars are capable of carrying that current without any problem, but not necessary that the load that I'm feeding is requiring of 4000 ampere. Maybe the need of that load is lesser than that. So in that scenario, I will attach a panel, or I will have a panel which is, let's say, maybe only rated for 2000 ampere, and which is good enough for the load that I'm having. So in that case, if you see, the ratings are different. My bus bar continuous current is 4000 ampere, but my feeder continuous current is only 2000 ampere. So in that case, you will notice two different current ratings mentioned on the nameplate or maybe on the data sheet of the product. So you don't have to get confused between what are these two different rating. These are simply, one is for bus bar, one is for the load that we are feeding, right? So it is also called as the rated continuous current of the feeder. And this concept is also given in the IEC. So if you look at the IEC carefully, you will notice this sentence: some main circuit of an assembly, example, bus bar or feeder circuit, may have different values of rated continuous current. So it is also given in the standard. So it is perfectly normal to have these two different current ratings. And with this, of course, if your load is not requiring 4000 ampere, you can get a panel with 2000 ampere and maybe optimize the cost. So those are the two ratings that you will find on the nameplate of the medium voltage panel, and also they are very, very important. Well, which takes us to the next parameter that we have, which is the internal arc classification or IAC classification. Now, internal arc is one of the most worst kind of fault that may occur within the switchgear, within the panel, right? And it has the capabilities to destroy the panel completely. It can also create a damage to the nearby panels, and maybe the substation will go down completely. Or if the worst case scenario, if somebody is working in the vicinity of that particular panel, the life of that person may be in danger. And to avoid all these scenarios, certainly it's not something that we are looking forward to, it's something we must avoid. So for that purpose, what we are doing is we are testing the switchgear extensively for this internal arc duty, and it's one of the most stringent duty to go through. And you will notice that on the nameplate or on the data sheet, some sort of ratings are mentioned in front of the internal arc classification. Let us understand what is the meaning of that. Yeah, so if you see why this happens, basically, if you are connecting the bus bars to the cable or incoming cable, and some of the joints are loose, and slowly there will be sparking happening, and that sparking will maybe after 5-10 years down the line turn into the internal arc fault, the partial discharge. So very, very important rating, and every switchgear, medium voltage switchgear, also the ring main units will have this rating given to that. So you will find something mentioned as AFLR 40 kiloampere for 1 second. Now let us understand what is these different letter indicates. So the first letter that you see, A letter, indicates the access to the public. So by the way, these are defined by the IEC standard. It's not something that I have defined, but it is defined by the IEC standard and it is followed throughout the industry. So A indicates the access to the panel is restricted to only the authorized person. Clear? There is one more classification in this, the letter B. The letter B indicates that this panel is placed inside a public place, and maybe around that panel there will be public available. So these are the two categorization of this thing. So letter A indicates only restricted person or authorized person. Letter B indicates it's in the public place where the public is available. And next letter indicates a FLR, which is the panel is tested for all the three sides of it. So if you see, we have this front side, we have these lateral sides, and we also have the rear side. The test, the internal arc test, what was conducted for all these three sides, and no significant damage was seen from all these three sides. So that's why the rating is given. Now, certainly when we are testing, at what current level we are testing, and that you can see here. So you see 40 kiloampere for 1 second. This indicates that I have tested this panel for 40 kiloampere of internal arc for 1 second, and for all the three sides when it is having restricted access. That is the meaning of all this nomenclature that you see about the internal arc classification. Now, not necessary that you should be testing the panel from all the three sides. It is basically depending on the application. So you can see it can be tested for front and lateral only. So front side and both the lateral side, because since this is directly connected to the wall that we have in the back, so it is not required the AFLR classification here. But if there are some panel where you have the gap between the back wall and the panel, then it should be tested for the rear side as well, which you can see it from the image, right? So this is a very critical parameter about the internal arc classification. And when we discussed about the parameters of ringman unit, we also discussed about this. It's super, super critical, and it must have. Now, what does it mean? What does it mean that my cubicle or my panels are capable of carrying 40 kiloampere for 1 second of internal arc? So it means that, let's say, because of some situation, the internal arc has occurred, and that fault is very dangerous. So the cubicles are capable of adjusting that fault. So basically, what will happen if The fire is coming, there will be ducts provided on top of the panel, and via that duct, that fire, that smoke will be thrown out of the room or maybe diffused within those ducts. So those facilities are provided on top of the panel, and that is what this internal arc classification or IAC classification indicates. I hope this is clear. And which takes us to the next important parameter, and that is the bus bar configuration. Now, if you are coming from the high voltage side, you know something about the high voltage substation. You will notice that in the high voltage substation, we have different bus bar configuration. We have single bus bar, we have main and transfer bus, double bus bar, 1.5 breaker scheme, and other categorizations are there. But when we talk about the medium voltage, we mostly find two different types of bus bar configuration. One that is most commonly used, most widely used, is the single bus bar configuration arrangement that you can see on your screen right now. So this is the front view of the panel, and this is the side view of the panel. So you can see here, it's a single bus bar arrangement. Only one bus bar is running, and then all the feeders, all the equipment we have connected to this. And this is the side view of that. The second type of configuration that you will notice in the medium voltage is the double bus bar configuration. Again, this is the front view, this is the side view. You can see we have two different bus bar A and bus bar B. This certainly offers more redundancy, more reliability of the supply, but again, it will add to the cost. A significant amount will increase there. So you have to really figure out what is the application. Do you really need this kind of arrangement? And then accordingly make the choice. So this is the side view. You can see it has arrangement for both the bus bar A type bus bar, B type bus bar can run through that, and this offers more redundancy, more reliability of the supply. And this thing will also be mentioned on the product data sheet or maybe on the nameplate itself. You can even understand this by looking at the single line diagram that is given on the panel. Which takes us to our next parameter, and that is the rated short circuit braking and rated short circuit withstand current. Now, these two things are different. The braking capacity is different, the withstand capacity is different. Now, you will notice on the nameplate it is mentioned something like this: 40 kiloampere for 1 second, or maybe 31.5 kiloampere for 3 seconds, something like that is mentioned. Now, when it is labeled as the braking capacity, it is related to something that is capable of breaking the huge fault current, of course circuit breaker. So this braking capacity is assigned to the circuit breaker. But we also have other parameters in the cubicle which are not capable of breaking any sort of current. For example, a disconnector do not have any capabilities to break any sort of current. So for them, the withstand capability or the withstand current parameter is applicable. For disconnector, we will not be defining the breaking current because they don't have capabilities. If it is defined, certainly it's a mistake. So it will have withstand current capacity, and for them also it will be the same 40 kiloampere for 1 second. Right? So that is the differentiation between the braking capacity and the withstand capacity. Braking means the equipment is able to break that fault current successfully without any issue, without any problem. Withstand means the equipment is capable of withstanding that huge fault current for a defined period of time. So it's not continuous, it's for a defined period of time, which is 1 second in this case. Because by the time the circuit breaker is clearing the fault, of course, the equipment should withstand that fault. Otherwise, breaker cleared the fault, but rest of the equipments are damaged. It's of no use. And that's why this withstand capacity is so important, so that we have safe switchgear even in case of fault condition. I hope you are clear on what is the rated breaking current and what is the withstand capacity. Which takes us to our last parameter, and that is the IP and IK codes. Now, IP ratings is very common nowadays. The mobile phones are also having this IP category. So now most of the mobile phones are promoted with the higher rating. So IP65 and all, it is getting promoted. Similarly, this medium voltage panels are also having this IP rating, and which is very, very important. Now, what it indicates, it simply indicates the level of protection provided by the switchgear enclosures. Remember this word, enclosures, against the ingress of solid objects. The first digit indicate the solid object, and the water, which is indicated by the second digit. And the common IP ratings you can see here: IP20, 31, 43, IP54, 55 is also there, 65 is also there. Now each of this digit, the first digit indicate the solid object, the second one indicate the water. It has meaning, every digit, so we are not going into that details in this video, but it has that details. And for outdoor use, generally the IP54 or IP55 rating is preferred, and it is related to the cubicle, the outside cubicle that we have. It's not something which is given to inside of any of the components, but outside the panel. And if it is a GIS panel, a GIS switchgear, then it may have two different IP ratings. One, the IP rating for the complete tank, because in that tank there will be all the switching devices, and of course we also have outer the enclosure. So it may have two different ratings. The tank will have different rating, and the cubicle panel will have a different rating. So that is IP rating. Now, when we talk about IP rating, we mostly forget about the IP rating, but it is again also very important rating. Now, what it indicates the equipment's resistance to external mechanical impact, which can be caused because of vandalism, then accidental collisions or intentional tampering. Yeah, certainly that is interesting one, intentional tampering. But yeah, you don't know if somebody is trying to interfere to the switchgear panel. So this IK code indicates the capability of the panel to withstand those mechanical impacts. Now again, this code 05, 04, 03, 6, 7, 8 indicates the different capabilities of the panel, which again we are not discussing in this video, but it's very important parameter, and I think you should understand when you see it IK05 mention something, that means it's a IK rating which indicates the mechanical resistance of the panel. Now let us go and quickly summarize these 5 different parameters that we talked about. So first, we discussed the rated continuous current of the busbar, which indicates the capability of busbar of carrying the current continuously. It can go up to 5000 ampere, and not necessarily the feeder that we are feeding the load will have the same current capability. It may have different or lower current capacity, not higher, by the way. Remember that it will have lesser or the same, but not the higher one. Then we also discussed about the internal arc classification. We saw the different character and their meaning. We discussed A indicates access to the restricted public, B indicates access to the public. Then we saw the sides of the panel, AFLR, and the current for which it is tested, 40 kiloampere, 31.5, 25, and different ratings are there. Then we saw 2 different busbar configuration, the single busbar and the double busbar configuration. Double busbar configuration provides redundancy. So in case one bus fail, you will transfer all the load to the different bus and thereby maintaining the supply continuity. Then we talked about the short circuit breaking capacity and short circuit withstand capability. So breaking capacities are generally related to the circuit breakers, and withstand capabilities are for the non-switching devices or the devices which are not capable of handling or breaking the huge fault current. And lastly, we talked about the IP and IK code. IP code is for the ingress protection, which is for the solid objects and water. It has different code. And the IK rating is for the strength of the cubicle to handle the mechanical impacts. So those are the 5 crucial parameters we talked about. Now, when we talk about medium voltage switchgear, there is one more parameter, which is loss of service continuity category. Now, this is also a very interesting parameter to know about. Now, if you want me to make a video on this, then definitely comment LSC. If I get enough comment, then definitely I'll be making a dedicated video explaining about this particular category. It's definitely interesting one. So I hope you understood the key parameter about the medium voltage switchgear. If you are interested learning more about the medium voltage switchgear, I have a dedicated playlist on that, link for which I'll provide down in the description. Definitely go and check it out. You will learn a lot of things from that as well. Thank you so much for watching, guys. I'll see you in my next one. But till then, keep watching, keep learning.